तो यार अब अपन देखेंगे इंटरफेसिंग सेंसर विद आर्डिनो रास्पबेरी पाई का हार्डवेयर। पहली चीज आती है एनालॉग टू डिजिटल कन्वर्शन which is also called ADC. It can be used in cases when analog signal is being produced by the sensor but microcontroller computer system expects a digital input. ठीक है। फिर आता है ADC एनालॉग डिजिटल कन्वर्शन converts a continuous time and continuous amplitude analog signal to a discrete time and a discrete amplitude digital signal. Now we have the performance of an ADC. The performance of an ADC is primarily characterized by its bit depth, bandwidth, and signal to noise ratio. The bandwidth of an ADC is characterized primarily by its sampling rate. For faithful same sampling and in analog signal having highest frequency of n Hz, the sampling rate of ADC should be at least 2 n Hz as per Nyquist-Shannon sampling theorem. Now we have the bit depth in the number of bits of information in each sample. So now we have the things that we have covered right here, the performance, the bandwidth, the bit depth. Now we have the sensor, the SNR of ADC depend upon many factors such as quantization error, aliasing, jitter, all these things. Now we have the quantization error is affected by voltage resolution, linearity and accuracy. So we have seen the things. So you can see the pictures of the ADC conversion. That is analog to digital converters. So now we move on. So these are few points about what different pins mean and what are the functionalities of each of these pins. Now we have the programming of Arduino. So Arduino is programmed using the C and CPP language, programming language, which is embedded C. Using a standard API, which is also known as the Arduino programming language, which is inspired by processing language. Arduino project provides an integrated development environment, which is nothing but IDE. Program written in Arduino IDE is called a sketch. Sketch files have the extension of .ino. So now any sketch has at least the following two functions. ये दो functions होते हैं at least. Setup function initializes the variables, input output pin modes and libraries being used by sketch and is called once. When a sketch starts after power up or a reset, it is analogous to the function main in a C programming language. Loop function. Loop function is executed repeatedly until Arduino is powered off or, or is reset after setup function ends. The function is analogous to while in C programming language. Now we have the Arduino language provides some built-in libraries to interact with different hardware on Arduino board. The libraries auto control shield board and any sensor is provided by their manufacturer. So now we have the interfacing sensor with the Arduino Raspberry Pi, this is a simple basic code that we can run. A sample Arduino sketch to turn on or off LED provided on Arduino board. This is a sample Arduino file that we can say. So this is the programming of Arduino. Okay, so now we move. So these are some of the basic analog temperature sensors. This is a sketch file to read analog temperature sensor. In C like we have defined the constant and going to void setup, calculation temperature, float, constant, return, function, delay, float, enter. These are we are familiar with some of the program. If you are familiar with some of the programming language, we must be knowing these things. So now we move on. So now we have the software part. So in this, the Raspberry Pi is a miniature ARM computer system. What does it mean? Raspberry Pi is a miniature ARM computer system with USB and networking support. Hence, modern operating system can be installed on it. The default OS is a Raspberry Pi OS, formerly called Raspbian. A Debian-based Linux distribution. However, other Linux OS variant such as Ubuntu, Fedora, etc., the Windows 10, IoT Core, RISC OS, Haiku, etc. can be used. There's no problem with that. Now, with being a computer, Raspberry Pi can be programmed in any language, having ARM compiler, interpreter. Raspberry Pi Foundation promotes Python and Scratch as the main programming languages, with the support to many others. Python built-in libraries can be used for controlling hardware on Raspberry Pi. For other specialized sensor, usually manufacturer provide the library. Need for sensing and monitoring infrastructure. So what is the need for monitoring and sensing? So infrastructure are meant to serve for long period. Like design life of them could be 100 plus years, you know. However, the usage is linked to individual preferences and community needs, which can change dramatically even every decade. Hence, infrastructure may get loaded due to increased load, change in usage pattern, changing climatic factors during its design life. For ascertaining the reliability and resilience and enhance adaptability of any planned infrastructure, continuous monitoring is needed. Infrastructure should be designed to be adaptable to satisfy the demands. However, old engineering design practices are rigid and mostly consider static climatology, which has led to issues related to aging infrastructure in cities. For example, UK National Infrastructure Plan, report card for America's infrastructure. To predict the upgrade of these aging infrastructure, continuous monitoring is required. Different types of infrastructure have different issues. For instance, localized failure in a linear infrastructure such as railway, roadway, power transmission lines, pipelines, flood embankment, etc., has the potential to affect the entire infrastructure. In such cases, earlier warning system driven by sensors along the infrastructure can help in avoiding any catastrophic failure. Modern sensing techniques for infrastructure. So microscopic devices incorporating both electronic and moving parts may consist of central unit that processes data and several components that interact with the surroundings, such as microsensors. Apart from mechanical components, MEM's sensors offer major advantages in terms of smaller size, lower power consumption, more sensitivity to input variable variations. cheaper cost due to the mass production, and less invasive than larger devices, and extend the performance and lifetimes over conventional systems. Now we have the modern sensing techniques for infrastructure. So previously we have seen these, some of them. Now we'll see in most cases MEM sensors are one miniaturized form of sensor of conventional size. Okay, so now we move on. These are some of the pictures that you can see. Yeah. So क्या की फाइल